Click-through rates, conversion rates, and activation percentages are the most common metrics computed in industry. Interviewers use this question to test if you write defensive, production-grade SQL that handles zero-denominator events and missing relationship joins safely. In standard SQL interviews, computing user activation rates, click-through rates, or confirmation rates is extremely common. But there is a silent production killer waiting for you. If a single user has 0 requests, your direct division will trigger a division by 0 crash. Let's look at how to build bulletproof mathematical safety. Here's the mistake that fails the interview. You perform a left join, sum the confirmed requests, and divide directly by the total count of requests. But in SQL, if a user signed up and never requested a code, the count of requests is 0. Dividing by 0 instantly crashes your production pipeline. When a database engine encounters a division where the denominator is 0, it halts execution and throws a runtime exception. To prevent this, we must intercept the 0 value before the query engine performs the division. This is where NULLIF and 3-valued logic become our primary shield. To solve this, we use NULLIF on our count denominator, matching 0. If the count is 0, NULLIF returns null. The division then safely evaluates to null instead of crashing. We wrap this entire expression inside a coalesce to map that safe null back to 0. Finally, we multiply by 1.0 to avoid integer truncation. Here's an advanced detail. If you write count star instead of count of column, the query engine will count the outer join null rows as one request. This gives users with 0 requests a false rate. Always count the specific column from the right-hand table to keep 0 event counts accurate. Lock in this blueprint for every SQL interview. Never perform a direct division without division by 0 protection. Always use NULLIF on your denominator and wrap the expression in coalesce to handle 0 event defaults. This is how you write production-grade, crash-proof SQL. Let's analyze the unsafe direct division approach. Time complexity, ON. Space complexity, ON. Fails with a runtime division by 0 crash in production if any user has 0 requests. Let's analyze the safe left join and NULLIF approach. Time complexity, ON log N. Space complexity, ON. Highly optimized by modern cloud databases using hash joins and safe vector division. The interviewer will then ask, why did you use NULLIF instead of a simple case? When? NULLIF is cleaner and more declarative. It returns null when the count is 0, which makes the division evaluate to null instead of throwing a divide by 0 crash, and we then map it to 0 using coalesce. The interviewer will then ask, what is the difference between count asterisk and count column in this query? Count asterisk counts every row, which would count a left join row with null as 1, skewing our rate. Count circa action only counts non-null values from the right table, which correctly evaluates to 0 for users with no requests. The interviewer will then ask, how would you optimize this query in a high-throughput real-time pipeline? I would pre-aggregate the confirmations table by user ID before joining to the signups table. This reduces the join cardinality to 1-to-1, avoiding broad join explosions and speeding up execution.